Welcome to tutorial on Introduction to PCB Design using KICAD. Chapter 1 Opening a Project and Getting Started. By Department of EEE NITT. Double-click on KICAD icon to open KICAD. Select New and then Project from File menu or press Ctrl N. From the dialog box, give name to project and choose the location to save. Now in the next window we could see two files, namely schematic and PCB files. Click on Schematic Editor. Now we are in KICAD Schematic Editor or Schema. We could start adding new components. Click on Place Symbol button, each required component from the Open Dialog tab. For example, search for voltage source. Place the component in required place. Place the other components such as diode as before. Tips: R for rotation and M for moving. Now to connect the components, click on Wire option or press W key. After connection our circuit looks like this. Add other components as before and wire it. Welcome to Chapter 2. Assigning values to schematic and generating netlist. From the design sheet, enter the values of the components. Double-click on the component to edit values or press E on hovering over component. In the next tab opened, enter the value of the component as per the design and enter OK. Similarly, enter the values of the other components as before. Next, press on Annotate Schematic icon to give number to the schematic components. In the next tab we can select required style of numbering here. Click on Annotate. Let's now start assigning footprint to the schematic. Click on Assign Footprint to Schematic button. Now Assign Footprint tab opens and we can select from the required footprints. There are 4 ways of selecting footprint for our symbol. 1. Filtering by schematic symbol. 2. Filter by pin count. 3. Filter by library selected. 4. Filter by partial name or pattern you enter in search box. On right side option, select the required footprint for the component. Double-click to assign footprint. Then click on View Selected Footprint icon. Here we can see the footprint. To get visual output of 3D image on PCB, we can click on 3D icon. This gives a 3D image in PCB output. This is an example for our diode. This is 3D image of our diode. After selecting footprints for the components, click on Apply Save Schematic and Continue. Then click on OK. Then click on Generate Netlist button. In the next tab click on Generate Netlist button. Keep default format for now. Then give suitable name and save in required location. Thus we have successfully generated netlist for our schematic diagram. Welcome to Chapter 3. Creating PCB trace in PCB New Editor. Now to generate the PCB trace, open PCB New Editor here or from the main menu. Now PCB New opens. Now to load our generated netlist, click on Tools and Load Netlist. In the next tab click on Read Netlist. If netlist was not stored in default location, change the netlist path. Then press Close button. Click anywhere on PCB New to place the components. Now we need to arrange components. Press M to move, R to rotate. Connections of components will be shown with white line. Slowly arrange the components as required by your design. Thus, after arranging components, now it's time to give copper traces to each connections. But before giving copper trace, make sure to check the current value from design specification. Here to find the trace width, go to main menu and click on KICAD Calculator and go to Track Width. There enter the current value and corresponding trace width will be generated. Now to add trace width, we have to change in Design Rules. Click on Setup and Design Rules. In the next tab in Design Rules Editor, select on Global Design Rules tab. Then enter the values in Track 1, Track 2 etc. Then click OK button. Herein we could see our added tracks listed here. Click on 0.3 mm to start our trace. Now to join the two footprints. Click on one footprint and drag to other. We could also see the connected footprints only be highlighted. Similarly connect other footprints. Now we could see problem. There is copper trace in between, so to overcome these issues we have to make a bypass using via.
Let's go back to our PCB cross-section. A via is almost exactly like a through hole in the board. In fact, it's made the same way. The copper and substrate layers are drilled, copper is added using an electroplating process. However, vias are usually much smaller than through holes as they aren't meant to hold pins or wires. Their purpose is simply to connect traces or copper between layers. If you have a trace on the top layer and you want to connect it to the bottom layer, you would use a via.
To place a via, right-click and select Place Through Via or simply V. Then connect the footprint. It will be connected at by bottom copper layer. That is by green color trace. Thus complete other connections as before with top or bottom copper trace or using vias. Then click on Electrical Check. Then in the next tab click on Start DRC. We could see problems and unconnected items in our circuit if present. Then click OK to continue. Now to add borders and boundary to our PCB, click on Edge Cuts in Layers. Select Polygon tool and start giving boundary to our PCB layout. After completing the border, it looks like this. Now to view our board, click on View and click on 3D Viewer. Now we can view our board output. We can save this as PNG for future reference. Giving name to our board. To give name to PCB, select Front Silks layer. To print text on PCB board, select on Text button. In next tab type the name on a, select OK. Place it inside the PCB borders. Similarly we can also add version and other details on other side of board by selecting B Silk screen layer. If we view our PCB in 3D viewer we could see our completed PCB with writings. Also we can align the namings of each component as per spacing neatly. Now to export our PCB design, click on File and Plot. In the next tab select the output directory. Then click on Plot. After that click on Generate Drill Files. Next tab will open, select Output Directory and click on Generate Drill File and close. Let other settings be default. This is last step in PCB design. Select the Gerber drill files and make it to zip or RAR format. This can be sent to PCB manufacturing company so that they can print your board. Thank you.